Okay, folks, now we're going to do some practice questions with reasoning to solve problems. So similar stuff to what we did in the last section, only now we're actually just doing some test type questions. So first one, what will be the ones digit for the expansion of 7 to the power of 98? Okay, well that's obviously something we're going to have to do by induction. I can't deduce that from any previously known ideas. So let's just look for a pattern with powers of 7. So 7 to the power of 0 is 1. 7 to the power of 1 is 7. 7 squared is 49. 7 cubed is 343. And you can use your calculator for this part, although I don't think it'll tell you what 7 to the power of 98 is. So 7 to the power of 4. What do we have for that? 7 to the power of 4. I'm getting 2401. And then 7 to the power of 5, let's see, 7 to the power of 5 is 16807. And let's go a couple more. 7 to the power of 6, that's 117649 if you win the lottery. And then 7 to the power of 7, in my slanting pyramid of numbers here, is 823543. So this question looks really ridiculously difficult when you start off, but all you're doing is looking for a pattern here. We've got 1793, 1793. I just said, what's the ones digit? Okay, so all the numbers where the exponent is, well, it's every 4 that we're repeating here, right? So that's our pattern. We repeat the ones digits every 4. And all the ones that are divisible by 4, like 0 and 4, they end in a 1. Okay, so is 98 divisible by 4? Nope. But if we can figure out the remainder, if it is divisible by 4, it would end in a 1. If it had a remainder of 1, the answer would be 7. A remainder of 2, we'd have 49. A remainder of 3, we'd have end in a 3. And again, we're back to divisible, so it would end in a 1. So let's see what the remainder is when I take 4 and I divide it into 98. Whew, long division. Haven't done this for a while, I bet. So we get 2 4s go in there, and we get an 8. We drop subtraction, right. Whew, long division, long time for me too. And then how many times does 4 go into 18? I guess that's 4 times. So we've got 16 there and a remainder of 2. So if the remainder of 2 is 2, it should end in a 9. Hey, that looks nice. Ends in a 9. Okay. Kenny only has a 3-liter container and a 5-liter container. Poor Kenny. Explain what he can do to get exactly 1 liter of water in one of his containers. Okay, Kenny, so we're trying to get 1 liter of water in one of your containers here. So let's say this container holds 3 liters, and this container holds 5 liters. What are we going to do? Well, 3 is closer to 1 than 5 is, so let's fill that one up first. So we fill this one up with 3 liters. All right. And then let's take it and dump it into the other one because we don't really have anything else to do with it. So if we do that, our 3-liter container now is empty, and our 5-liter container will contain 3 liters of water. Now remember, I've got to get it down to 1 liter here. Well, I don't want to put anything in here because that's kind of a special thing. So let's fill the 3-liter up again. So fill the 3-liter up again. Oh, and then if I dump that one into the 5-liter as much as I can to fill it, then that'll take 2 liters out of this. Aha! So we're going to subtract 2 liters here, and that'll leave us with just 1 liter in our 3-liter container. Okay? So I guess if we're going to write that out, we'd fill the 3. We dump into the 5. Dump it into the 5. And then fill 3 again. And then use it to fill the 5. And then you have 1 liter left. Nice. Okay. So when solving by induction, use specific examples to try to decipher a pattern like we did with those 7s. When solving by deduction, organize the information if you have any. We drew a picture. And then use logic to try and make connections. And sometimes with deduction, you got to play around with it before the pattern comes out at you there, or the ideas come out at you.